Welcome to the Earth Our Habitat, Geography, Class 6, Major Domains of the Earth, Part-3. Having learnt about the land and water surface, in this module, we will be discussing about atmosphere, composition of the atmosphere, layers of atmosphere, how the earth and its atmosphere get heated, atmospheric pressure, then another layer, biosphere, and at last some fun activity. So far we have discussed about lithosphere, hydrosphere, and in this module we will be discussing about atmosphere and biosphere. The envelope of air that completely surrounds the earth is known as atmosphere. It is the presence of the atmosphere with its abundant supply of oxygen that makes the earth a unique planet in the universe. The oxygen in the atmosphere has been responsible for the origin and growth of life on earth. Let us discuss about composition of the atmosphere. The atmosphere is a mixture of many different gases and tiny solid particles. 78% of air is made up of nitrogen and 21% of oxygen. Although these gases are plentiful and of great significance to life on earth, they are of little importance in affecting the weather phenomena. The remaining 1% of dry air is made up of a number of gases. Let us discuss about the importance of some of the gases. Role of nitrogen. Nitrogen is important for plants because plants make many important molecules from nitrogen. Since we get food from plants, hence nitrogen is also important for us and for all other animals. So the nitrogen is essential to maintain fertility of soil. And helps plants to grow. Role of oxygen. Oxygen is required by living beings for respiration. Moreover, oxygen is also required for burning various fuels. So oxygen is the breath of life. Role of carbon dioxide. Carbon dioxide is utilized by plants during photosynthesis. You may recall that photosynthesis is the process by which plants make food. Carbon dioxide also helps in trapping the heat from the sun and prevents the heat from escaping the atmosphere of Earth. Thus, carbon dioxide helps in maintaining an ambient temperature on Earth. So, carbon dioxide helps plants to manufacture food and help absorb heat to keep the Earth warm. Ozone, another gas found in a small quantity, is extremely important as it protects the Earth from the harmful ultraviolet rays of the sun. Let us discuss about the layers of atmosphere. So Earth's atmosphere has a series of layers, each with its own specific traits, moving upward from ground level. These layers are named the troposphere, stratosphere, mesosphere, thermosphere, and exosphere. The exosphere gradually fades away to the realm of interplanetary space. The density of the atmosphere varies with height. It is maximum at sea level and decreases rapidly as we go up. Look at the picture, the different layers of the atmosphere. It is maximum at the sea level and decreases rapidly as we go up. You know, the climbers experience problems breathing due to this decrease in the density of air. They have to carry with them oxygen cylinders to be able to breathe at high altitude. The temperature also decreases as we go upwards. The atmosphere exerts pressure on the Earth. This varies from place to place. Some areas experience high pressure and some areas low pressure. Air moves from high pressure to low pressure, and this moving air is known as wind. So before learning more about the layers of atmosphere, let us watch a small video of the atmosphere. watched a small video of the atmosphere must have understood the importance of the atmosphere. Why it is important for us. An important domain in the earth. Now let us discuss one by one about all these layers. Troposphere. The troposphere is the lowest layer of our atmosphere, starting at ground level. It extends upward to about 10 kilometers. That is 6.2 miles, about 33,000 feet above sea level. We humans live in this troposphere, and nearly all weather occurs in this lowest layer. Most clouds appear here, mainly because 99% of the water vapor in the atmosphere is found in the troposphere. Air pressure drops and temperatures get cooler as you climb higher in the troposphere. The next layer is stratosphere. Stratosphere extends from the top of the troposphere to about 50 kilometers, that is 31 miles above the ground. The infamous ozone layer is found within the stratosphere. Ozone molecules in this layer absorb high energy ultraviolet light from the sun, converting the ultraviolet energy into heat. Unlike the troposphere, the stratosphere actually gets warm the higher you go. Look at the picture again. The first layer is of troposphere, then we have the stratosphere, mesosphere, thermosphere, and exosphere. Watch this image. Troposphere, stratosphere, mesosphere, and the thermosphere. Let us discuss about mesosphere. Above this stratosphere is the mesosphere. It extends upward to a height of about 85 kilometers, 53 miles above our planet. Most meteors burn up in the mesosphere. Unlike the stratosphere, temperatures once again grow colder as you rise up into the mesosphere. The coldest temperature in Earth's atmosphere is about minus 90 degrees centigrade, found near the top of this layer. Now let us discuss about thermosphere. This layer of very rare air above the mesosphere is called the thermosphere. High energy X-rays and ultraviolet radiation from the sun are absorbed in the thermosphere, raising its temperature to hundreds or at times thousands of degrees. However, the air in this layer is so thin that it could feel freezing cold to us. In many ways, the thermosphere is more like outer space than a part of the atmosphere. Many satellites actually orbit Earth within the thermosphere. Look at the image. This is the thermosphere. The satellites and other bodies, they move in this layer. let us discuss about the exosphere. Although some experts consider the thermosphere to be the uppermost layer of our atmosphere, others consider the exosphere to be the actual final frontiers of the Earth's gaseous envelope. As you might imagine, the air in the exosphere is very, very, very thin, making this layer even more space-like than the thermosphere. So this was about the different layers of the atmosphere and their importance. Now this atmosphere has some effects on us. The atmosphere protects the Earth by preventing all the sun's radiations from reaching the Earth's surface. It acts as a huge filter keeping out harmful ultraviolet radiation, while letting some of its heat to heat the Earth and lower atmosphere. By doing this, the atmosphere also prevents the Earth from getting too hot during the day. Now how the Earth and its atmosphere get heated? After studying about the layers of the atmosphere, you have understood the importance of the different layers of the important for us. Now, you know that sun is the ultimate source of energy for us. We cannot think of life without the solar energy. So how the Earth and its atmosphere get heated? Let us discuss about insolation. The incoming solar energy from intercepted by the Earth is defined as insolation. So the incoming solar energy intercepted by the Earth is defined as insolation. Look at the picture. Earth, the incoming solar energy. This is insolation. All life on planet Earth is due to the solar energy which is received by our atmosphere. So some part of the solar energy is received by us, by the Earth, and the sun is radiated back. A considerable amount of insolation is reflected back into space by clouds, snowfields and oceans. The atmosphere absorbs only 14% of the incoming solar. So it absorbs only 14% of the incoming insolation. What is insolation? You have already learned that the incoming solar energy intercepted by the Earth is defined as insolation. Look at the picture carefully. So the atmosphere protects the Earth by preventing all the sun's radiation from reaching the Earth's surface. It acts as a huge filter keeping out harmful ultraviolet radiation, while letting some of its heat to heat the Earth and lower atmosphere. By doing this, the atmosphere also prevents the Earth from getting too hot during the day. The carbon dioxide and water vapor in the lower layers of atmosphere absorb the heat radiated from the Earth's surface and keeps the atmosphere warm even during the night. This is known as the greenhouse effect. The heating of the Earth's atmosphere is two different temperatures produces circulation in the atmosphere. leading to winds and precipitation. All forms of life are affected by the difference in weather conditions during different seasons. So all forms of life are affected by the difference in weather conditions during different seasons. So you learnt about the insolation. The sun energy travels to the earth as electromagnetic radiations, which can be thought of as energy moving in waves. There are short waves and long waves. The incoming solar radiation is received in the form of short waves. Heat in the form of short waves not as easily absorbed as the long waves. And a considerable amount of insolation is reflected back into the space by clouds, snowfields and oceans. And interesting to know that the atmosphere absorbs only 14% of the incoming insolation. Now the sun's heat energy is absorbed by the earth and atmosphere during the day. At night, this heat, which is absorbed by the earth and its atmosphere, is radiated out by the earth and its atmosphere. So it is reflected, radiated back by the earth and its atmosphere. The sun energy absorbed by the earth's surface and radiated out into space is called terrestrial radiation. So remember, the sun's energy absorbed by the earth's surface and radiated out into space is called terrestrial radiation. The atmosphere is heated more by terrestrial radiation giving out by the earth than by the incoming insolation. The atmosphere is heated more by terrestrial radiation than by the incoming solar radiation. The atmosphere also gives out the heat absorbed, thus a balance is maintained between the amount of heat that enters the Earth's atmosphere and that which leaves it. The atmosphere spheres acts like a blanket. So this is important to note that the atmosphere is heated more by terrestrial radiation given out by the Earth than by the incoming solar insolation. And at night the atmosphere keeps the Earth's surface warm by prevailing all the terrestrial radiation from escaping. So it is acting like a blanket for us. During the day the atmosphere prevents the Earth from becoming too hot by not allowing all the insolation to reach the Earth. Thus you can say the atmosphere prevents extremes of temperature. Without the atmosphere, the earth will become very hot during the day and very cold at night. to note that land gets heated through the process of conduction. As rocks are bad conductors of heat, insulation heats up the thin surface layer quickly. And water surfaces get heated by the process of convection. Insulation goes below the surface of water to a greater depth than on land and is distributed over a larger volume. Now let us discuss about atmospheric pressure. Atmospheric pressure is the pressure at any point on the surface of the earth due to the weight of the column of air above that point. Why do we need to study about atmospheric pressure? The study of air pressure is important to the geographer for the following reasons. It creates winds, it influences weather forecasting, and many more things. So atmospheric pressure is not the same at all places. At sea level, the pressure varies from place to place according to the change in temperature. At sea level, when the temperature increases, the atmospheric pressure decreases. Look at the image. With increase in height, the gravitational pull of the earth decreases and the density and pressure of air decreases. So, as the height increases, the gravitational pull of the earth also decreases. You know the fact. And the density, look carefully. And pressure of air also decreases. You know the fact that climbers experience problems in breathing due to this decrease in the density of air. Now there are factors affecting atmospheric pressure. One is altitude. Atmospheric pressure decreases with increase in altitude. The decrease in pressure is about 1 centimeter of mercury for every 110 meter of ascent. Reason being, air is compressible. Look the image carefully. Earth's gravity pulls the molecules of air and other gases downwards towards the ground. The lowest layer is therefore the most greatly compressed, hence the density. The dense layer closer to the surface of the earth exerts a greater pressure in the rear of less dense layers higher up in the atmosphere. Temperature is also one of the important factors affecting atmospheric pressure. Reason being, when the temperature rises, the air expands. The molecules of air move far apart, become less dense. Look carefully. And hence exert less pressure. Water vapor, moist air exert less pressure than dry air. Reason being, moist or humid air is lighter than the dry air. This is because water vapor or humid air displays an equal volume of dry air, nitrogen and oxygen. Thus, a given volume of humid air contains comparatively less nitrogen and oxygen than dry air, and is lighter or less dense. Hence, it exerts less pressure. So, effect of air pressure is that winds are caused due to differences in air pressure. Warm air is light. As it rises, it cools and spreads. Once it has cooled, the air starts to sink backward. So you know the fact that winds always move from high pressure to low pressure. The reason where the air sinks, an area of high pressure is created. Since the atmosphere constantly works to restore a balance, air moves in the form an air of high pressure to an area of low pressure. And this movement of air is known as wind. So I hope you must have understood about the atmospheric pressure. Now let us discuss about biosphere. The narrow zone of contact between the lithosphere, hydrosphere and atmosphere is called biosphere. Life exists in this zone. A variety of organisms exist on Earth. All the living beings are linked to each other for their survival. They are also linked to various non-living things for their survival. Look at the image carefully. So atmosphere, hydrosphere, lithosphere, where they meet, makes a biosphere, the living world. The organisms in the biosphere can be broadly classified into the plant kingdom and animal kingdom. The three domains of the earth interact with each other. They also affect each other in some ways or the other. So we need to take good care of our environment. Otherwise, the existence of life will be in danger on our planet. If we cut forests on large scale to clear land for human activities, this will lead to removal of topsoil. Removal of topsoil can be harmful in the long run, because soil is necessary for agriculture and for plant growth. We create a lot of waste which ends up polluting the environment. So therefore, the three domains of the earth interact with each other. And affect each other in some way or other. The earth's surface may be changed due to natural calamities like earthquakes. For example, there could be submergence of land, as happened in the case of tsunami recently. Parts of Andaman and Nicobar Islands were submerged underwater. Discharge of waste material into lakes and rivers make the water unsuitable for human use. It also damages other forms of life. Emission from industries, thermal power plants and vehicles pollute the air. Carbon dioxide is an important constituent of air, but increase in the amount of CO2 leads to increase in global temperature. This is termed as global warming. There is thus a need to limit the use of resources of the earth to maintain the balance of nature. between the domains of the lithosphere, the atmosphere and the heterosphere. So this is all in this module. Hope you must have understood atmosphere and biosphere along with other domains, lithosphere, hydrosphere. At last, some fun activity for you. You must have seen the aircraft or jet planes fly. Can you explain why a jet plane flying in the sky leaves behind a white trail? Think it and try to answer. Thanks. You hope you must have understood the major domains of the earth. Meet you in the next module.